and then we'll. Okay. I'm sharing my screen. Can everyone see my screen? Can you go do a thumbs up if you can see it? Okay. All right. So I know all of you have studied HCF and LCM in school, isn't it? So we'll still do a small recap before we start. Okay. Let's say I have three numbers, 24, 60, and 72. Okay. So let's say I want to find the LCM. What is LCM? LCM is the least or lowest common multiple. And HCF is the highest common factor. Some of you may have also learned it as GCD, greatest GCD, isn't it? Greatest common divisor.
Ma'am, in some schools I heard that they even taught like HCD and GCF.
Oh, is it? Okay. Okay. 1 second. Okay. So I have these three numbers. And today we are going to see HCF and LCM by prime factors. So what do? I have to find the prime factors of 24, isn't it? Some of us do the factor tree. 2 taken 12 times, 2 taken 6 times, 2 taken 3 times. Yes. And 60 is 2 taken 30 times, 2 taken 15 times, 3 taken 5 times. And then when I have to do 72, 2 taken 36 times, 2 taken 18 times, 2 taken 9 times. So I stop when I reach a prime number. Yes. Okay. And so 24 can be written as 2 into 2 into 2 into 3.
Ma'am, it is also called as 2 cube multiplied by 3.
So I can also write it as 2 cube taken 3 times. And then 60 is into 2 into 3 into 5. So I can say that is 2 square.
Multiplied by 3 multiplied by 5.
And then 72 is
2 cube multiplied by 3 square.
yes, 2 into 3 into 3. So I can write it as 2 cube into. Now to find the
Also write as 2 into 3 whole square multiplied by, okay, actually no, doesn't matter.
but so if we write like this, it helps us. We'll see shortly why. So if I want to find the let's say HCF of these three numbers. So what are the prime factors of these numbers? 2, we have 2, 3, and 5. But for HCF, we will write only the prime factors that are common for all three numbers. So the common prime factors are 2 and 3. And then we will choose the exponent, which is the lowest. So for,
Ma'am, 2.
yeah, for 2, I have 3 as an exponent and 2 as an exponent. For HCF, we'll choose the lowest exponent. So we'll choose 2 square. And for 3, the exponent that I have is, I have 2 and this is 1, isn't it? So I'll choose the lowest exponent, 1. 2 square is 4. 4 into 3 is 12. So the HCF is 12. So for HCF, we chose only the common prime factors. For LCM, we will choose all the prime factors. We'll choose 2, we'll choose 3, and we'll also choose 5. But instead of the smallest exponent, we have to now choose the biggest exponent. 3.
Biggest exponent, because the LCM is nothing but a certain combination which will contain 24th prime factorization, 60th prime factorization, and 72th prime factorization.
Yes.
And
So,
HCF,
yeah. So the LCM is 360. Yes. Or I can also think of it as I choose the common factors. So for what are the common factors? There is 2. All of them have 2. Again, all of them have 2. And all of them have 3. So for HCF, I can also say I'll choose only the common factors. So HCF is 2 into 2 into 3, 12. So for LCM, I'll write the common factors once, 2 into 2 into 3, and then I'll also write the rest of the factors. So the rest of the factors are 2 into 2 into 3 into 5. Both of them are the same principle. Yes. Does anyone have any questions?
no, ma'am.
Okay. Shall we then go to?
There is one extra 2 into 2 into 3 into 2 into 2 into 3 into 5.
So did I leave out a 3 or a 2?
Yeah, on the wait. Yeah,
I have a
no, in the top LCM, in the LCM on top which you wrote, no, there. Yeah, it's not supposed to be. Wait, yeah, the top one is correct. The bottom one you only have to write 2 3 times, right?
I wrote 2 times, right? Correct, right? We have to choose the highest exponent. See, there are, if you see the X here, we have 3 2 times, isn't it?
And then we have, but we have 2 4 times.
Yeah, where we
In
have 2 3 times. We have 2 2 times, and we have 3. Oh, here we have 4 times. Okay. Okay.
But the method wise it is correct, but if we do it the prime factorization wise, the exponent wise, it's coming a different answer. One of them is correct and one of them is different.
Which one is wrong?
I'm not sure.
So 360, is it divisible by 24? 60
Yeah.
and 72. Yes.
Yeah,
So,
yeah, it's not about that, but but in the bottom, like if we look, we can see that two of the twos are common, okay, but then 24 and 72 both have 3 twos, but 60 does not have 3 twos. But so
okay, I see what you're saying. This one, there is 1 2 is missing, isn't it? 2 into
no,
2.
no, no, it's not that. It's not that. Oh, See, on top you have to like wait. Can I click the animate button?
Okay.
Yeah. So even because there are three, so it's different. So you have to do this one and this one. You have to take it as 1 2, not 1 2. Both of them you have to take as 1 2. So that's why.
Yeah. Yeah. Both of them we have to take it as 1 2. Yes. So we have, that's why it's remove the extra 2 here.
Oh yeah. Okay.
Okay. All right. So shall we go on to the word problems? Can you see the first problem?
Yes.
Okay. So 4 bells ring at intervals 4, 6, 8, and 14 seconds. They start ringing simultaneously at 12 noon. At what time will the bells ring together the next time? We'll take 2 minutes for everyone to solve the problem. And if you have the answer, you can ping me. You can send the message to me. Yes, I'll check it. Don't shout out the answers. Give a chance for everyone to solve it.
Ma'am, I've sent my answer. Is it correct?
I'm checking it. Darsh, can you check your answer again? Jitendra also, can you check your answer again? Yeah, Vallabh, you are correct.
Am I correct?
Saket, can you check again?
Ma'am, Saket's answer in there to everybody.
Oh, oops. Sorry. I forgot to click that.
That's
Oh,
okay. Be careful next time.
it's wrong anyway.
Yeah. It's okay. It's okay. It takes a little practice, isn't it? But be careful. Yeah. Jitendra, you need to be a little bit more precise.
Ma'am, I sent my new answer. Is it right?
Ma'am, I sent my answer. I tried my answer correct.
Yeah. Johan, your answer is correct. Shresha, I think it's a type mistake. Shivansh, it's correct.
Ma'am,
Harsh, can you try again?
ma'am,
Yeah, who is it?
I'm Karthi Varman.
Did you send your answer? I don't see your answer here.
No, ma'am, I can't understand this question.
Okay, okay. So let's go through the question. There are 4 bells, okay, and the bells ring. So the first bell rings. I think one of you has to mute your. Can you please check? I hear some noise. Okay,
There's a
thank
fan sound.
you. Okay, thank you. Can you mute yourself, Shrestha? Okay, thank you. So there are 4 bells, and these bells, they ring at intervals of 4 seconds, 6 seconds, 8 seconds, and 14 seconds. So let's say it's 12 noon. Okay. So all the bells, all the 4 bells are ringing. Let's say the bells are A, B, C, and D. Okay. Let's say the bell or bell 1, bell 2, bell 3, and bell 4. Okay. At 12 noon, so at 12, bell 1 is ringing, bell 2 is ringing, bell 3 is ringing, and bell 4 is ringing. Now what happens after 4 seconds? After 4 seconds, bell 1 rings. So that is 12 o'clock and 4 seconds. Bell 1 is ringing. The rest of the bells, they don't ring. Now after 6 seconds, bell 2 is ringing. So at 12 noon and 6 seconds, bell 2 is ringing. The other bells are not ringing. And then after 8 seconds, bell 3 is ringing. Bell 1, bell 2, and bell 4 are not ringing. Then after 14 seconds, bell 4 is ringing. Okay. Now the question is, when will all the 4 bells ring together?
Ma'am, I said the answer. Could you see?
Yeah.
Ma'am, I also sent before. I think.
Yeah. Yeah. Jitendra, it's correct.
Ma'am, my name is Vijay Krishna.
Can you rename yourself? Okay. Ahan, correct. Viraj, I think you left out the last digit. Yeah, Saket, correct. Okay. Vijay, correct. Shiven, right. Okay.
Ma'am,
Let's look at the solution.
ma'am,
Yes, Shrestha.
ma'am, is my answer correct? I3 actually.
Okay, let me see. Shrestha, yeah, I think there is a typo. I think you missed 1 digit, but I
Ma'am,
think
I3 not Shrestha.
sorry. Can you guys rename yourself? Otherwise, it's very difficult for me to remember everybody's names. Okay. So we know that the bells ring after 4 seconds, 6 seconds, 8 seconds, and 14 seconds. So how do we solve this problem? If I find the common multiple of 4,
They'll see.
6, 8, and 14, yes, that is the time the bells will ring together, isn't it? So because this one repeats after every 4 seconds, bell 2 repeats after every 6 seconds, bell 3 repeats after every 8 seconds, and bell 4 repeats after every 14 seconds. So all 4 of them will ring at the same time when they have a common multiple. So what are the prime factors of 4?
Ma'am, 2 into 2.
2 square. Yes.
Ma'am,
Yes.
ma'am, when bell 3 rings, then bell 1 will ring, ma'am, because 8 is a multiple of 4.
Yeah. Yeah. But we are interested in when all 4 of them will ring together. Yes. So prime factors of 6 is 2 into
3.
and 8 is
2.
and 14 is 2
2
into
into 7.
7. So we know to find the LCM, we have to include all the factors. We have to include 2, we have to include 3, and we have to include 7. And we have to take the highest exponent. So the highest exponent of 2 is 3, and 3 is 1, and 7 is also 1. So it is 8 into 3 into 7. What is 8 into 3 into 7?
Ma'am, 168.
168. So the bells will ring again together after
168 seconds.
168 seconds.
Which is equivalent to 2 minutes and 48 seconds if you are going to convert it to
Yes. But
12
the question
colon.
is, at what time? We want to know at what time they'll ring together. isn't it? So 1 minute is 60 seconds. So,
So 2 minutes 48 seconds.
so 168 is divided by 60 is 120 seconds. And whose fan is it, guys? Can you mute
Miss
yourself?
Reshta's, I think so.
Reshta, can you mute yourself? Okay. 120 plus 48 seconds. 120 is nothing but 2 minutes 48 seconds. So after 12 noon, so if it is 12 noon, the next time the 4 bells will ring together is 12 minutes, sorry, 12 o'clock, 2 minutes and 48 seconds. Okay. Any questions?
We can go ahead.
Okay. Let's go to the next problem. Here is the next problem. Can everyone see it? Find the smallest number which when divided by 12 or 10 or 8 leaves remainder 6 in each case. So what does the question say? Question say there is a number. Let's say that number is x. So when I divide that number by 12, I get a remainder of 6. The same number, when I divide it by 10 also, I get a remainder of 6. I divide it by 8, still the remainder is 6. And they want the smallest number.
Ma'am, I sent my answer. Is it correct?
Yes.
Is my answer is correct, Arnav Shinde?
You don't have to ask. I'll check the chat. Yeah. Let's give everybody some quiets to work out the problem. Yeah. Okay. If your answer is correct, I will not reply. If you need to rework, I will reply. Okay. So if you Arnav, can you check again? Shivan, check. Shivan's check. Vallabh, think little bit.
MSN maths.
Yeah, okay. Agnay, okay.
Wait, ma'am. Won't check it yet. 1 minute.
Okay.
Ma'am, is my answer correct?
If it's correct, I won't say anything. Huh? So if you want to work again, I'll tell you.
Yes, ma'am. Now you can check.
Okay, I think most of you got it right. Okay, let's try it. Let's solve it.
Ma'am, 1 minute, ma'am. I'm trying.
Okay, who is this? Ahan.
Sreshta.
Okay, Ahan, can you check again? Jitendra, Ahan. Can you all? Yeah, Vallabh, correct. Ahan, Shivain, check again. Naitik, can you also check again? Okay. Okay, let's try and solve it. Okay, Nidhi, check. Yeah. So we have a number which when divided by 12, 10 and 8, it always gives the same remainder. But we know that if we have a common multiple of 12, 10 or 8, if I have the LCM of 12 will be, what will be the remainder when I divide it by 12, the LCM of 12, 10 and 8? It's a multiple of 12, isn't it? So the remainder will be 0. So when I divide the LCM of 12, 10 or 8, when I divide it, the remainder will be 0 because it is a multiple. Is everyone clear with this idea?
Yeah. Yeah, we are subtracting 6 from the answer we want, and then we can add 6 in the end.
So just hold on, Saket. So we know that if I have a common multiple, it is a multiple of 12, it is a multiple of 8, and it is a multiple of 10. So the remainder will be 0. But we want, when you divide, the remainder to be 6. So how do we go from there? Let's find the LCM first. What are the what are the prime factors of 12? 2 square, 4 into 3. 10 is 2 into 5. 8 is 2 cube. What is the LCM? We have to include all the prime factors, 2, 3, and 5. And we have to take the highest exponent. Highest exponent of 2 is 3. Yes. And 3 is 1. 5 is 1. 2 cube is 8.
8 into 3
8
into 3 into 5.
into 5 is how much?
120.
120. So now I know 120 divided by 12, remainder is 0.
0.
So you
Because
have to
it is
add
a
plus
multiple.
6.
Yes, 120 divided by 8, remainder is 0. 120 divided by 10, remainder is 0. But we need a remainder of 6.
Ma'am,
So
we can add 6.
So we should add 6 for
yeah. So if we add 6 to the LCM, if we add 6,
126.
126.
6.
Okay. Somebody had subtracted 6. Will that work?
No, ma'am.
No, ma'am. Ma'am, they said that you subtract 6 and then add 6.
Subtract 6 and add 6.
Yeah, in the first you subtract 6 and then in the end you add 6.
Say that again. Avnay.
Ma'am, no, ma'am, not me. Somebody said like they'll add my subtract 6.
Ma'am,
is,
if we
first-
subtract 6, if we
Mhm.
subtract 6, we should again add 12, ma'am.
Yeah.
Yeah.
Because yeah, that won't work, isn't it? Okay. Shall we go to the next sum?
What's the answer? Is not 126. What happened?
The answer is 126. No?
Oh, okay. Yeah, got it.
Okay. So let's go to the next problem. Okay. There are 21 mango trees, 42 apple trees, and 56 orange trees that have to be planted. Yes. In rows such that each row contains the same number of trees in one variety only. Minimum number of rows in which the above trees may be planted is, so what are they saying? I have mango trees. I'm going to plant them. So let's say mango trees, I write it as M. So I'm going to plant mango, 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 mango. Yes, mango, mango, mango. Apple, apple, apple. Orange, orange, orange. So I have to plant them in rows like this. I have to plant such that each row contains the same number of trees in one variety only. So there are two conditions. Each row should have the same number of trees. That is the first condition. Same number of trees. So if you are planting in groups of 4, they should have only 4. If you are planting in groups of 5, there should be only 5. And the second condition is that I cannot plant 2 mangoes, 1 apple, 1 orange. No. Everything should be of the same variety. So each row should have
Ma'am, I sent my answer.
right. Okay. So how many such rows is the question?
Ma'am, I sent my answer.
the answer.
Ma'am, even I sent the answer.
Yes, ma'am. I also sent before.
Guys, please give others at me. I will check the chat. You don't have to let the others, give them some quiet to solve the problem. So read the question again. The number of rows, not how many trees in that, even though that is part of the question. They want to know the number of rows. So many of you answered me the number of trees in each row. What total number?
Ma'am, your voice is breaking.
Ma'am, we can't hear you.
If your answer is
Ma'am, am I correct?
sorry.
Ma'am,
Voice is breaking.
ma'am, your voice is breaking a lot. You can try turning off your video. That will be.
Can you hear me now?
Yes, ma'am.
Okay.
Is my answer correct?
So, Vallabh, can you check? Ahan, Vallabh, can you check again? Yes.
Ma'am, is my answer correct, Aitreya?
If your answer is correct, you won't get a reply from me. Yes.
Yes, ma'am.
Ma'am, is my answer correct?
Ma'am, my answer is correct. Arna Shinde.
Please don't repeatedly ask. Give some quiet for others to check. If your answer is correct, you won't get a reply from me. If you have to check again, I'll call out your name. Yes. Agne, check again. How many rows? Ahan, Vallabh, Agne, Abhinav. How many rows?
Yes, ma'am. Ma'am, what?
So the question is, what is the minimum number of rows in which the above trees may be planted? Okay, let's.
Ma'am, I have a question on the. I have a question.
Yes, Agne. Yes, Agne.
So, minimum number of rows in which the above trees can be planted is okay. So, my question is, for one tree, like for the mango trees, apple trees, orange trees, which tree will take the least amount of rows? Is that the question?
It is asking the total number of rows. So maybe if I say the total number of rows, will that help?
Oh, okay. Okay.
Hmm?
Thank you.
Okay. Okay. So what are they asking? They want the mango trees, the 21 mango trees, 42 apple trees, and 56 orange trees to be broken down into rows. Yes, and all the rows should have the same number. Each row should have one variety and the same number of trees. So that gives us a clue that it has to be a factor, isn't it? The trees have to be broken down into the same number. So that gives us a clue that it is a factor and that we are looking for a common factor. Yes. So let's break down 21. 21 into prime factors. It is 3 into
3 and 7.
7. And what about 42?
7 into 3 into 2.
2 into 3 into 7. What about 56?
2 cube into 7. 2 cube into 7.
2 cube into 7.
2 cube into 7.
Yeah.
7,
we-
7 is the only common factor here.
Yes. So we know that we are talking about factors because the trees have to be broken down into the same groups. So we are looking for the highest common factor. So when we calculate the highest common factor, we write only those factors which are common for all three of them. 7 is the common factor. So we know that the mango trees are going to be planted in groups of 7. So I have mango 1, 2, 3, 4, 5, 6, 7. Again, the next row will also have 7. So many of you had answered 7 correctly. But that was not the question. The question was how many rows? So there are 21 mangoes. If they are arranged in groups of 7, they will take up how many rows?
So they need 3 rows.
3 rows. And
Mango.
there are 42 apple trees. If they are arranged in groups of 7,
6 rows.
6.
they will take up 6 rows. And there are 56 orange
8. They need 8 number of rows.
rows.
So my answer was correct only.
So
Yes.
so if we add up, there are 17.
If I add all of them, so the minimum number of rows I have is
17.
17 rows.
My type 17 only.
Okay. Okay. Any questions? Shall we go to the next problem?
Yes.
And we can also find the number of columns with this.
Yeah. You want to arrange them in vertically here like this apple. What do you mean?
There will be 7 columns.
Yeah, they can be arranged in rows or in columns. Yes.
Ma'am, why
Ma'am,
don't
but
we
when they
use
can
the
be
L method?
Sorry,
Why don't we use the L method?
L method. We can use the L method. That is also, if you are comfortable with that, you can use that.
Okay.
Okay. I just wanted to highlight that we are doing this based on prime factors and that we are taking the common factors. Sometimes when you do the L method, it's not very visible that. Yes, but that is also fine. Okay. All right. Let's go to the next question. Okay, this is the next question. Find the greatest number which when divides 259 and 465 leaves reminders of 4 and 6 respectively. So let's say this greatest number, let's say it is x. So this number, when it divides 259, so when it divides 259, it gives a reminder of 4. And when it divides 465. It gives a remainder of 6. What is the number? Please post your answers in the chat. And if it is correct, you will not get a reply. If not, I'll tell you. Okay. Yes, Shivansh, you have a question?
No, ma'am.
Ma'am, I sent my answer. Is it correct?
Who is it?
Darshraj.
I sent my answer, Nikhil.
Yeah, you don't have to tell it. I'll check and I'll reply. Yes. Let's be gives others some time to solve. Yes. Agne, I'll explain it again. There is a number. Yes.
Ma'am, sorry, I typed it wrong. I understood the question, but I don't know how to proceed with it.
Okay. 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 So I've got enough number of answers. Shall we discuss the solution? Okay. Yes, Aitreya correct. Shayon correct. Okay.
Is my answer correct, Nikhil?
Nikhil, I don't think I got
And
your.
Saket, am I
I
correct?
replied, no? I replied to yours.
Ma'am, can I explain?
Who is it?
Ma'am, Vijay Krishna.
Yes, Vijay, go ahead.
Ma'am, so the number should divide so a number should divide 259 and 465 by leaving a remainder of 4 and 6 respectively, ma'am.
Yes.
So we have to subtract 4 from 259 and 6 from 465 and find the HCF of the differences.
Okay.
So
So what Vijay is saying is from 259, we have to subtract 4, we get 255.
55.
and that is the remainder. Yes. So from 259, we have to subtract the remainder that we get. And then from 465, we have to subtract the remainder 6. And we get 459.
459.
Then Vijay says, find the HCF of 255 and 459.
Yes.
So what are the prime factors of 255?
Ma'am, 5 into 17 into 3.
5 into
17 into 3.
3. And what are the prime factors of 459?
3 square into 17 into 3.
3 square
Oh,
into
3 cube.
yeah, 3 cube.
Sorry, 3 cube.
Well, no, it is 3 square because 3 square is 9 and it is 9 multiplied by 51.
Ma'am, it's only 3 square, ma'am, because 9 into 17 into 3.
Yeah.
3
9
square into 17 into 3.
3 cube, isn't it then?
So yeah, 3 cube into 17, yes.
3 cube into 17.
17.
But what is the HCF?
17 into
of
3 because
yeah,
because there are 3 number of 3's in 459. So 17 and 17 adds up to 117 and 3 and 3 adds up to 1. 17 into 3 is
so
equal
we
to
write only the common factors. So we write only 3 into 70.
70.
But we take the lowest exponent. So we are going to take 1 and 1, and the answer is 51.
51.
So why did Vijay say we have to subtract 4 from 259?
Ma'am, can I tell?
Yes.
Ma'am, because it will not have a reminder. The reminder will be 0 and we can find the exact number.
So we know that the number that we are looking for x, that is x, does not divide 259 exactly. It gives a remainder of 4. So for example, if I have, let's say I'm dividing 19 divided by 4. Yes. So 4 4s are 16. Remainder is 3. So 4 does not divide 19 exactly, isn't it? It has a remainder of 3. There is an extra 3. We can think of it like that. I have an excess of 3, which I was not able to divide among 4 people. What if I remove this extra 3? Will I be able to divide it among 4 then? So let's say from 19, I remove the extra 3. What is the number that I get? 16. Now 16 is divisible by
4.
4. 4 4s are 16. So that is why Vijay is saying remove the remainder, remove the extra. So once I have removed whatever was remaining extra, so I removed the 4 and I removed the 6. Now 255 is divisible by x and 459 is also divisible by x. So if I were to divide 255 by the number we want, we'll get remainder as 0. And 459 also will get remainder
0.
as 0. Now we have to find what is the number that will divide 255 and 459 and give us a remainder of 0. So we are looking for a factor. We are looking for a number that will divide both 255 and 459. So we are looking for a common factor. And we want the greatest such number. So we want the highest common factor.
HCF.
HCF. So I find the HCF of 255 and 459, and that is 51. So now when I divide 259 by 51, what will be the remainder?
0.
259.
No,
4 4 4.
4.
Isn't it?
And 465 465 divided by 51, remainder will be as given in the 6.
Okay. Yeah. Does anyone have any questions?
No, ma'am.
Everybody is clear with this idea?
Yes.
Okay. Shall we go to the next sum? Agne, is it clear?
Yes, ma'am. Ma'am, I came until subtracting that, but I didn't know how to proceed from that. I just subtracted it and I didn't know how to, but now I understand.
Oh, okay, okay. Isn't it? And then you have to just find the common factor.
Okay, ma'am.
Okay.
Ma'am, your screen will get frozen, but then your voice is good sometimes, but sometimes your screen is good and your voice is bad.
Is it happening to everyone?
No, ma'am.
Yes, ma'am.
Yes, ma'am.
No, ma'am. Yes, ma'am.
So how many of you have this problem? Can you show a thumbs up? Okay, I see 2. So not everyone is saying it. So maybe it's just for a few of you, 3 or 4 of you. So maybe you can check your internet connection.
Ma'am, it's just that bar is very full.
I think not everybody has that problem, Agne. So maybe you can check your internet connection.
Ma'am, actually, it's like that rare period of time. Like that.
Sorry, Vijay, what was that?
No, ma'am, your voice is going ahead of your screen, and sometimes the screen is going ahead. Like that, sometimes it's happened.
Is it
Not
happening?
always, but like once in a while.
Okay, okay. While you solve this problem, let me switch my internet connection. We'll see. Yes, I'll
Okay.
explain this problem and then I'll switch the connection.
Okay.
Okay. Find the least number which when divided by 8, 12, and 6 leaves reminders 6, 10, 18 and 34 respectively. So there is a number, it's the lowest number. Say that is x. So this number, when I divide it by 8, x divided by 8, I get a remainder of 6. The same number x, when I divide it by 12, I get a remainder of 10. And when I divide it by 18, when I divide it by 20,
20, the remainder is 18.
yeah, yeah. The remainder is 18. And when I divide it by 36, the remainder is 34. So the question is, what is x? Okay, let's do it. I'll just change my connection. Okay, I am replying to your answers in the chat. Don't worry about it.
And is my answer correct?
I have replied to all the messages I have got. Who is this?
Abhinav.
Sorry,
Ma'am, Abhinav.
I haven't received your message. Can you send it again?
Yes, ma'am. Yes.
Check again, Shivansh. Abhinav, can you check again? Yes, Nidhi, correct. We want the lowest number. Okay. Shall we discuss? Do you want some more time?
And some more time.
Okay, let's give it one.
Ma'am, actually, there should be 4 numbers, right?
For what, Vijay?
Find the least numbers given, but there should be 4 numbers.
4 numbers. Why do you think so?
Ma'am, because when we find the LCM, it is 360.
Okay. Huh. Okay, I see what you're saying. Okay, you're almost there.
Yes.
So it's not a different number for that you're going to divide by 8. A different number you're going to divide by 12. It's all the same number.
Okay.
So see, it is the same number. It is X. The same number is being divided by 8. It is being divided by 12. It's being divided by 20. And it's being divided by 36. But it gives a different reminder.
Yes.
Okay. So shall we solve?
Ma'am,
Ma'am, can I
2
tell how?
minutes.
Yes. Who is it?
Aitreya.
Okay, Aitreya. Go ahead.
Ma'am, actually, if the reminders are different, right? So,
Yes.
if we add the reminders to the numbers respectively, then the number will be exactly divisible by the the number.
Okay.
So we have to add like the number to the reminder.
So you want to add X plus 6?
Yes.
Okay.
No, ma'am.
Hmm.
Ma'am, 8 plus 6.
Okay. 8 plus 6. Okay.
12 plus 10 and 20 plus 18, 36 plus 30.
20 plus 18, 36 plus 30. So what do we get? 8 plus 6 is 14.
And
12 plus
22, 38,
Mhm.
and then 70.
Okay.
Ma, if we divide x with these numbers, then the remainder will be 0.
Okay.
As we want the
X
least,
divided by 14, then remainder is 0. X divided by 22, remainder is 0. X divided by 38, the remainder is 0. X divided by 70, the remainder is 0. Okay.
ma'am, as we want the least number,
Mhm.
we have to find the LCM of these 4 numbers.
Okay. So what are the prime factors of 14? 2
2
into
and 7.
7. 22 is
2
2 into
multiplied by 11.
38 is 2 into
Uh,
19. Okay. 70 is
2 multiplied by 5 multiplied by 7.
okay. So what is the LCM? For LCM, we need all the factors.
Common factors.
2 into 5 into 7 into 11 into 19. What is the answer? 5 into 7 into 11 into 19.
Ma'am, the answer is 14630.
Does this work?
Ma'am, for the 8 plus 6 equal to 14 part, I'm not sure.
Yeah. Let's check that again. Does this logic hold? Yes. Let's say I have a number 19 and I'm dividing it by 5. Yes. 5 threes are 15. The remainder is 4. Okay. So what Aitra is saying is when I divide 19 by 5 and the remainder is 4, what I do? I add the 4 to the 5. So when I say 19 is now divided
19
by,
divided by 9 is not divisible.
then the remainder she says is 0. Is this working?
No, it is not.
Ma'am.
Okay, that's okay. All right. So does anyone else want to share their solution?
Yes, ma'am.
Who is this?
Ma'am, can I?
Saket.
Shivansh,
Ma'am,
Shivansh, you
Ma'am,
want to share
Saket?
yours?
Saket.
Hold on.
What,
Saket.
ma'am?
Shivansh, you want to share your solution?
Yes, ma'am.
Okay, go ahead.
Ma'am, so like what I noticed was that the remainder was 2 less than the numbers given. Like with the number 8, the remainder was 6, with 12, 10, 20,
So-
18, and 36, 34.
Okay, so we have,
So
hold
what
on.
I did was that I took the LCM and subtracted 2 because that was the
Shivansh.
common difference in these.
Shivansh, hold on 1 second. So when we divided x divided by 8, remainder was 6. When x was divided by 12, remainder was 10. When x was divided by 20, remainder was 18. When x divided by 36, remainder was 34. Yes, Shivansh, what did you observe?
That the common difference between the remainder and x was always 2.
But we
And
don't
the
know
divisor,
x.
sorry ma'am.
So the difference between the divisor
Yes,
8
ma'am.
and 6. So the difference between 8 and 6 is 2.
2.
The difference between 12 and 10 is also 2. The difference between 20 and 18 is also 2. The difference between 36 and 34 is also 2. Okay, Shivansh, go ahead. Shivansh, go ahead.
Ma'am,
What
so
do you do?
now I noticed that if we take the LCM and subtract 2 from it, this condition would be fulfilled.
LCM of what, which numbers?
Ma'am, 8, 12, 20, and 36.
So you will now take the LCM of 8, 12, 20, and 36. Okay. So 8 is, what are the prime factors of 8?
2 power 3.
12 is 2 square.
2 power 2 squared into 3.
20 is 2
2
square
squared into 5.
5. 36
2 squared into 3 squared.
square into 3 square. So the LCM would be, we have to take all the factors 2, 3, and 5, but we have to take the highest exponent. Highest exponent of 2 is 3. Highest exponent of 3 is 2, and that of 5 is 1. So what is the answer? 2 cube is
Ma'am, 360.
8 into 9 into 5. That is 360. Okay. Now what
Ma'am,
did you?
so like,
Hmm.
ma'am, as the common difference was 2, I subtracted 2 from the LCM.
Okay. So what he did, he took the LCM 360, and this was the common difference between the divisor and the remainder. So, okay, you got 358. Okay.
And this part,
Yes,
can
ma'am.
I explain more, ma'am? This part
Hold on.
to make it more simple.
Hold on, Saket. Shivansh, are you done?
Yes, ma'am.
So you are saying x is 358. So 358 divided by 8, you'll get remainder is, sorry, 6. And 358.
Ma'am, what if the difference was not the same? Like
Ah.
if different.
Yeah, that is not. We'll see why that is not possible to solve. Yes, I think Saket, you wanted to share something. Saket. Okay. Can you hear me?
Yes, ma'am.
You wanted to share something?
Yes, ma'am.
Yes, go ahead.
Yeah. So basically we can have a number 360. So
Hmm.
like what you can do this -2, like don't directly do it first. So if you see 360 is obviously LCM of 8, 12, 20 and 36. So if you divide 360 with 8, the remainder will be 0. 360 with 12, the remainder will be 0, and so on with 20 and 36. But
Yes.
we want the remainder to be 6 and 10 and 18 and 34. So
Yes.
what we can do, what we achieve by doing -2 is
Mhm.
also we make it like the reason we do -2 is that we make it 34 still left to be minus to get the next multiple. So what I mean is, let's say we have 16, okay, which is a let's say 24, which is a multiple of 8. Okay,
Okay.
so if
Okay.
we -2 from it, we get 22. And if we have to -6 more to make it to get the next multiple of 8, which is 16. So that
Yes.
is why we can get that the remainder will be 2 less. And
Okay.
using this, we can minus 360 and 2 and get 358 as the answer.
Okay. Okay. So that's what Saket is trying to explain as to why this subtracting 2 works. Okay. Let me also try explaining it. So I have a number that is 358. Okay, let's take a different number. Let's start with x. Okay, so we say x is when I'm dividing x by 8, I'm saying x is 8 into some a. I don't know what that a is. 8 into a, and I get a remainder of 6. So can I write x is 8 into a plus 6? Is everybody okay with that? Now, instead of multiplying 8 by a, what will happen if I multiply 8 by a plus 1, the next number? What will be the remainder then? What I mean is, suppose I have a number, say, let's say 18 divided by 8. Okay. 8 twos are 16. What is the remainder? 2. Yes. So instead of taking 8 taken 2 times, let me, which is what we usually do. Let's say for argument's sake, I'll take 8 taken 3 times. 24. What is the remainder?
-6.
It is -6, isn't it? So if I go to the next quotient, I get a negative remainder. Yes. So if I do the regular division algorithm, my remainder is 6. But if I go to the next quotient, what will be my remainder? I'm already 6 short. Yes. Let's take a number. Let's say 16 is divisible by 8, isn't it? Let's say 22. So when I divide 22 by 8, 8 twos are 16. What is the remainder? 6. This is what we have here, 6. But instead of taking 2 times, let me take 3 times. 8 threes are 24. What is my remainder then?
I'm -2.
-2, isn't it? So if I choose A, the remainder is +6. If I choose A plus 1, the remainder is -2. Everybody's okay with this?
Yes, ma'am.
Yes, Saket. Anybody else? Any questions?
No, ma'am.
Okay. So can I also write x as then 12 into some b? I don't know what, but I'm getting the remainder as 10. But what if I divide instead of by B, instead of using B as a quotient, I go to the next quotient. I overshoot. I use B plus 1. What will be the remainder?
Negative.
So, let's take a number. So if I need 10 as a reminder, let me take 34. Let me divide by 12. 12 twos are 24. I get a remainder of 1. Okay. Now, instead of using 34, 2 times, let me go 12 taken 3 times. 36. What am I getting the remainder as?
Ma'am, -2.
-2.
And there is one more other simple way to do this. So we can write this 10 as we can write 12b plus 10 as 12b plus 12 minus 2. Okay, then take 12 common, 12 into b plus 1 and then minus 2.
Yeah, so we can write this 6 as 8 minus 2. 12, 10 as 12 minus 2. So it would be 12 times b plus 1 minus 2. Yeah. So I can also, then I can write x as 20 times c plus some remainder 18, or I can write it as 20 times c plus 1 minus 2. And I can write 36 into some d plus remainder as 34, or I can write 36 into some d plus 1 minus 2. Is everybody okay with this? Any questions?
No, ma'am.
Ma'am, what if it was different?
We'll come to that. Yeah, wait. Yeah. So now we know, let me remove this. Okay. We are not interested in this. We want this. Okay. So we know x is this. So can I say x should be a multiple of, common multiple of 8, 12, 20, 36? Yes, I find the LCM of 8, 12, 20, 36, which is 360.
Yeah, and also we have to take 2 to the other side. No, so n plus 2 is that. So minus 2. Yeah.
Then I subtract the 2. I get x is 358. Because x is a, I can write it as a multiple of 8, a multiple of 12, a multiple of 20, a multiple of 36, but it is too short being a multiple of 8, too short of being a multiple of 12, too short being a multiple of 20. Too short.
So we took that 2 short into the other side, it becomes plus. So
Yes.
x plus 2 is all this full LCM,
Yes.
and you have to minus that to get
X plus
by
2 is x plus 2 is a LCM of 8, 12, 20, and 36. Okay. So x plus 2 is nothing but 360. So x is 360 minus 2, 358. Okay. Any questions? Any questions, guys?
No, ma'am.
No, ma'am.
No, ma'am. No,
Some
ma'am.
presentation is on the screen. Can you remove it? I think I see a.
No, ma'am.
Okay, shall we go to the last question for the day?
Ma'am, can you do the different remainder?
Yeah, we'll do. We'll see what happens. Yes. If the reminder is different, who is asking the question?
Darsh.
Yeah, Darsh. So think about it. If the reminder is different, yes, will you be able to arrive at a solution?
Not in this method.
Yeah. But is there such a number that exists? Here the reminder is different, isn't it? But the difference is the same. You can play with the question. You can change it a little bit. Instead of the reminder as 6, why don't you change it as 5? Yes, so that the difference is not 2, the difference is 3. And see if you're able to figure out a method. We'll discuss it in next class. Yes?
In the next class.
Yeah.
Okay, ma'am.
You try it on your own and see if you're able to come up with the answer. If not, we'll discuss it in the next class. You with the same sum, try playing it around. Change the reminder to 5. Change the reminder to something else. So maybe keep 2 of them as 2. Change this one to 31 and say the difference is now 5. Yes. See if you're able to come up with something. Okay. 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 Now the next question. Given that HCF and LCM of 1764 and a number P are 36 and 8820 respectively, find the value of P. So there are two numbers. The numbers are 1764 and the other number we don't know. It is P. So the HCF of 1764 and P is 36 and the LCM of 1764 and P is 8820. So they are asking what is the value of P. Okay. As always, you can put your answer in the chat and I will reply to you. Yes. Okay, shall we discuss? We just have a few minutes. Most of you got the answer correct. Yes, Vijay. Does anyone want to share their solution?
Ma'am,
Shiva.
can I share this?
Sorry, who is it?
Ahan.
Ahan, you want to share? Okay. Go ahead, Ahan. Ahan, you're on mute.
Yes, ma'am. Sorry,
Ah.
ma'am.
No problem.
Ma'am, it is said that the multiplication of the HCF and the LCM
Mhm.
is equal to the multiplication of the two numbers.
So you're saying HCF and the product of HCF and LCM is the same as?
The product of the two numbers.
Yes, ma'am. I'm as a proof also.
Hold on, Saket. Let Ahan finish it. Yeah. So
So, ma'am, that's why we know that HCF and the LCM are 36 and 8820 respectively.
Okay.
We can get 1764 to the other side.
Okay.
So,
So I
divide.
divide by 1064 on both sides.
Yes, ma'am.
Then when I simplify, I
Uh,
think.
Ma'am, 1764 into 5 is equal to 8820.
Okay, so I think 49, 7, 1, 2, 6, 0.
Actually, no need, ma'am. 1764 into 5 is equal to 8820, right?
180.
Okay, so P is 100 and
180.
so Saket, you want to share your proof?
Yes, ma'am. Wait, let me just finish recalling it. I'll share at the end after everyone shares the solution.
So 180 is the solution. Most of you got it right. Yes. So shall we take a sample problem and try it, Saket?
Yes, ma'am.
Shall we take a sample problem and try it? We'll take a smaller number.
Yes, yes, ma'am.
You want to give the numbers?
Okay. I give the number 6
Mhm.
and any number with just preferably 2 prime factors. Okay, and let's take a 21. Wait, no, it has to have a proper answer. Wait, let me take 15. Okay, so what we can do, the HCF is like nothing but it can have more numbers, but we can write it as two numbers multiplied by each other, just any two variables. We can take A and B. No, proofs are supposed to be general, but okay, it's fine.
Can
So
explain a small.
yeah, okay. So now if you notice that the HCF is the numbers that are common. Okay, so in this case 3 is common in both 6 and 15. 3. Okay, HCF is 3 and LCM is the number that will be which will cancel out all the repetition. So in this case 3 comes 2 times, so we cancel it. So we cancel.
Yeah.
Yeah, so we just write 3 once and we write everything else 2 and 5. So imagine we are multiplying all of this 2 into 3 and 3 into 5. In this specific case, if you want to look at generally, imagine we are multiplying all of the prime factors. So then what will happen is that the HCF in the common ones, the HCF will be counted once, and the LCM will also count it, but second time. So if you look in this example, we have 3 in the HCF and 3 ones in the LCM. So if you multiply both of this, it will contain both the 3s and of course all the non-common factors in the LCM.
So if you multiply the numbers also, you are basically multiplying the factors.
Yeah. Multiplying 6 and 15 is equal to multiplying 2 into 3 and 3 into 5.
So if you look, basically multiplying the HCF and LCM is the same as multiplying the two numbers. They contain all the factors of both the numbers. So we know that the product is this. We can use that to find the other number.
Yeah,
Okay.
you can look at it as LCM is equal to the HCF, in this case 3, multiplied by all the uncommon one, and we also have the HCF multiplying again. So when we multiply the HCFs, it gets common, so it includes both 3s and all the uncommon variables we multiply. So that's why multiplying the HCF and LCM of two numbers will equal to the product of the two numbers.
So I'm just posting the homework. We'll stop here. We've reached the end of the class. Okay. Does anyone have any question?
No, ma'am.
So the next class will not be, tomorrow's class is not HCF and LCM. We'll take a break. We'll do prime numbers tomorrow. And then after we are done with prime numbers, we'll come back to HCF and LCM. Yes. So if you have done the homework, keep it with you. And when I come back next, we'll discuss it again. Okay. So those who have any questions about the homework problem or any other questions can stay back. Others?
These are the homework ones, right? These